We're going to be talking about different scenarios involving tangents, chords, secants, and the angles that they form. So, our first scenario is when you have a tangent line to a circle and a chord that meets it. These two angles that are formed. So what you have now is their angles are going to equal half of their corresponding arc. So angle 1 here is going to be half of this huge arc ACB. And angle 2, likewise, will be half of this arc, which is AB. So angle 2 will equal half of arc AB. So that's our first little scenario. And it should make some sense. Angle 1 plus angle 2 should equal 180 because they are on a straight line. And the arc that goes with angle 1 and the arc that goes with angle 2 equal 360. The angles are half of the arc. Our next scenario involves what looks like a railroad crossing sign. It has two chords that are intersecting in a circle. And this one is easy to remember because what you're going to do is you're just going to take the average of the arcs. Angle 1 is going to equal half of JH plus KI. So the angle equals the average of the arcs. So angle 1 in this case would equal 1/2 of JH plus KI. And our last scenario is when you have an exterior angle. This angle here is outside of the circle of trust, right? It is outside, so we want to subtract it away. We do not want it in our circle. So what's going to happen? These ones are the trickiest of all of them. You have to find where the two lines, whether it's two tangents, two secants, or a secant and a tangent like this, where do they actually intercept the circle? So they do so here, here, and here. So what we're going to do is we're going to say that the angle is equal to 1/2 of the big arc minus the smaller arc. So in this case, AC minus AB. This is where the lines intercept the circle. So angle 1 would equal 1/2 of AC minus AB. So just remember, when you're inside the circle, you are taking the average, you are adding the arcs together. When you're outside of the circle, you are subtracting it, you're removing it from the circle. So let's try a couple of examples. This first example is like the railroad crossing one. It's the one that's in the middle, and we just want the average of the arcs. If angle 1 had been here in the center, it would be the same as its arc. But since it's off center, we're just going to say that angle 1 equals half of 52 plus 148. Conveniently, 52 plus 148 is an even number, and we're going to get 200. So angle 1 equals 1/2 of 200. It's very easy to see then that angle 1 is 100. If you had gotten an odd number in this position here, all you have to do, instead of taking half of that odd number, you could double both sides of the equation. Then that would eliminate your need to take half of it. So angle 1 is 100, and that means that this angle over here, should they ask about it, is 80. So let's go over to this situation. This one is a little ugly. Normally, we would use, it's outside of the circle, so we would use our third scenario. But there's an easier way to do this horrible, horrible problem. The way we would do it using the method we just learned is that the angle is equal to 1/2 of the big arc minus the small arc. So 85 is going to equal 1/2 of, what is this mystery big arc? All right, we're just going to write big arc if we don't know what it is, minus x. Well, to get this big arc, we're going to talk about that in class. You would have to do, it would be 360 minus x. But we're going to go into why that is true in class. we're not going to do it this way because there is a far simpler way. And it only works when you have two tangents. It does not work when it's a secant. So what I'm going to have us do is this. I want you to draw your radius to the point of tangency. And I want you to think, what do you know about that angle from what we learned about tangents the other day? If you have a radius drawn to the point of tangency, recall that it forms a right angle. And likewise, it'll do the same thing over here. Now, go back to chapter 8 where we learned about quadrilaterals and think for a second. What do you know about all four-sided shapes? What is the sum of the interior angles? If you remember, quads equal 360 degrees. So, if you've used up 180 degrees here, how many degrees are left? This will be true of anything that has two tangents going to it. It will always form something called a kite. So you will always have a remainder of 180 degrees left. So if this is 85, what should this be? If you answered 95, you're correct. And if the central angle is 95, then its arc, x, is also 95. We're going to do it in class the long way using the method above, and you'll choose which one you like best. But here's a real scenario that involves the third one, and I want you guys to try that. You have a secant and a tangent. You need to do the angle equals 1/2 of the big arc that's being intercepted minus the small arc. Hit pause and try and get at least the numbers correct. In order to do this, we need to know what this big arc equals. We also need to know what this small arc equals. So you know that you have 100 degrees and 96 degrees. You will be able to find out what BA is equal to. So a little subtraction will get you that this is 164. So now plug in everyone you know and get the answer. And in 5 seconds, the answer will be revealed. You should get that angle 1 is half of 68. So angle 1 will equal 34 degrees. Bring any questions to class, and we will start learning about this next class.